Hi, in this video I'm going to introduce you to random numbers. Java provides a class called random, and it provides various methods for pseudo-random number generation. Let's have a look at some of those methods. Notice how many of them start with next, like next boolean, that gives you a random true-false value. Next double, that gives you a value in a fairly small interval between 0 and 1, 0 inclusive, 1 exclusive. Same is true for float. Both next double and next float give you a random number that is uniformly distributed. So sometimes you might want to simulate something that has a normal distribution, or also called a Gaussian distribution. That's a distribution that follows the bell curve. You want things to be more likely in the center and less likely on the fringes. If this is what you need, you can use next Gaussian. Once again, the value is between 0 and 1, but here the distribution is different. There is also something called next long that gives you a random long value, and Nextint. We're going to have a closer look at the overloaded method Nextint. Nextint comes in two versions, either without parameter or with an integer parameter. So this first version, without a parameter, provides you with a random number, and it could be any number from the whole integer range. Here I printed 50 random numbers using Nextint, and you notice all those numbers are fairly big. The reason is that my integer range goes from minus 2 point something billion to plus 2 point something billion, and most of the numbers in this range happen to be quite big. Many times we don't want to have those really large numbers. Many times we want to have random numbers from a more restricted range. Class random also provides a method called Nextint, where I can pass an integer. Let's read what the Java API says. It says Nextint, when I pass an integer, returns a pseudo-random uniformly distributed integer value between 0 inclusive and my specified value, that's n, exclusive. So I can say it gives me a value in the interval 0 inclusive, that's the rectangular bracket, to n exclusive, that's the meaning of the parentheses here. Let's look at an example. Let's say we call Nextint with 5. That would return one of the values 0, 1, 2, 3, or 4. 5 possible values. 5 was the argument we passed to Nextint. When we list all the possible values in order, it always starts at 0 and it always goes up in steps of 1. All the methods of class random are instance methods. So let's assume we have an instance of random. I call it rand. It's of type random, and I assign a new instance of random right here. Now let's look at some examples. Let's say I need a random value between 0 and 7 exclusive. So those would be 7 possible values, 0, 1, 2, 3, 4, 5, and 6. And in order to get one of those values, I can call rand.nextint and pass 7 as my argument. Notice I'm calling Nextint on my instance of random with my dot operator, because Nextint is an instance method. Another example. Let's say I need a random value from the following set, 0, 1, 2, 3, 4, 5. Those are 6 possible values, so I need to call Nextint with the argument 6. Now it's your turn. Give yourself a moment to come up with the Java statements that produce a random number in the described ranges. Pause the video. When you're done, press continue. So here I have 3 possible values, 0, 1, and 2, and I need to call Nextint with the argument 3. In my second situation I have 9 possible values. I need to call Nextint with the argument 9. Notice our range has always started at 0, and we were always going up in steps of 1. Now what happens if I don't want to go in steps of 1, but in a different step size? That's where scaling comes in. Let's look at an example. Let's say I need a random number of the set 0, 3, 6, and 9. Step 1, I'm checking my number of possible values. I have 4 possible values, and I'm going to call random Nextint of 4. This is going to return one of the random numbers 0, 1, 2, or 3. At this point, I have the right amount of possible values, but I have a different step size. I want a step size of 3, I have a step size of 1. So my algorithm needs a second step. I still have to come up with a transformation that changes the values returned by Nextint and returns elements from my desired set. So here I'm going to map 0, 1, 2, 3 to 0, 3, 6, and 9. I can do that by multiplying the original values with 3. So for example, 0 times 3 is 0, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So I could just say, give me a random next integer of 4 and multiply the result by 3. This way I get one of those elements, which is exactly what I was looking for. Notice also that the value I was multiplying with is my step size. This is exactly the difference between my possible set elements. One more example. Let's say I need a random number of the set 0, minus 4, minus 8. My step size is minus 4. First step is always the same. 3 possible values. I'm going to call rand.nextint with argument 3. This gives me 0, 1, 2. Right amount of possible values, but not the actual elements of my set. So I need my second step. I'm multiplying with minus 4 because my step size was minus 4. So random.nextint3 times minus 4 will return a random number from the set 0, minus 4, minus 8. Now it's your turn. Assume you need a random number of the set 0, 2, 4, 6, and 8. Give yourself a moment, come up with the Java statement that produces one of those values randomly. Pause the video, and when you're done, press continue. Here we have a step size of 2. The first step of the algorithm is always the same. We check the number of possible values. There are 5 possible values, so I'm calling rand.nextint of 5. At this point, I receive one of the values 0, 1, 2, 3, or 4. The right amount of values, but not the actual elements of my desired range. So I still need a second step in my algorithm, and I need to multiply with my step size, which is 2. If I say random Nextint of 5 times 2, I will receive one of those elements 0, 2, 4, 6, or 8. At this point, we talked about creating random numbers from a range or a set that starts at 0. But what happens if I don't want to start at 0? This I will discuss in the second part of the random video.